Let's get into some examples of integrals in various contexts. The graph of a differentiable function f is shown above for -3 to 3. The graph of f has horizontal tangent lines at -1, 1, and 2, and the areas of regions A, B, C, and D are 5, 4, 5, and 3 respectively. Let g be the antiderivative of f such that g of 3 equals 7. Here we're going to find the value of this limit, which is defined as g of x plus 1 over 2x. I see that my denominator goes to 0. If I can show that my numerator goes to 0, then I can use L'Hopital's rule. But my numerator is in terms of this function g of x, and I need to define what that is. We have this initial value, so we know that g of x is g of 3 plus the integral from 3 to x of f of x dx. So g of x equals 7 plus the integral from 3 to x of f of x dx. So now that I have g of x, I can use this and see if the L'Hopital's rule is going to work. So see the limit as x approaches 0 of g of x plus 1 equals g of 0 plus 1, which is 7 plus the integral from 3 to 0 of f of x dx plus 1. So that's going to equal 8 minus the integral from 0 to 3 of f of x dx. Now the integral from 0 to 3 are going to be the areas of C and D, which are 5 and 3. So this is 8 minus 5 plus 3, which is 0. So now we know that the limit as x approaches 0 of 2x equals 0. So by the L'Hopital's rule, the limit as x approaches 0 of g of x plus 1 over 2x equals the limit as x approaches 0 of g prime of x over 2. Now we can do substitution. This is g prime of 0 over 2, but g prime of x is f of x, so that's f of 0 over 2, and f of 0 from the graph is 0. So our overall limit using L'Hopital's rule is 0.